we learned chapter 4 is on trigonometry. Okay, so it's basically talk about right angle triangles for sine, cosine, and tangent values. Okay, so you must remember when we talk about sine, cosine, and tangent, it must be a right angle triangle. If it's not right angle triangle, you can't use sine, cosine, and tangent. Okay, that's the first you must remember. And we have three ratios. Okay, we have three ratios. Well, most of you will know that we have sine. Just wait a second. Okay. Okay. So we have three ratios: sine, cosine, and tangent. And for sine, SOH, SOHCAHTOA. Okay, I think that's most of you how to remember that. But for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. Okay, so that's the three ratios we have. And you know that, okay, for any right angle triangles with the same angles, these ratios are always the same. Okay, what that means. For example, I have a right angle triangle, like I said, that's 45 degrees, and I have 1, 1, and √2 for this right angle triangle. And I have another right angle triangle, have 45 degrees here as well, but obviously this one is bigger than the other one. Okay, I have 5 and 5 as the straight lengths, and have 5 √2 for the hypotenuse. Okay, even though the second right angle triangle looks bigger than the other one, but when you talk about the ratio for sine 45, cosine 45, and tan 45 degrees, it will be the same. Okay, so that will be the same. When you talk about sine 45, the first one will give you 1 over √2, and the second one will give you 5 over 5 √2. But when you cancel the 5, you will have 1 over √2 as well. So the sine ratio will be the same, even though it's in different right angle triangle. Even though this one looks obviously bigger than the other one, but it will be the same. And also those two right angle triangle will be similar triangles. Okay, if you can see that, they will be similar triangles. They all get the same angles, okay, in the corresponding side. Okay, 45, 45, 90, 45, 45, 90. Okay, that's this one. Okay, so for example 1 is some evaluation thing. Okay, some evaluation thing. We have like, okay, this represent a ratio. Okay, sine 45 degrees is a ratio. Okay, it equals to something. It's a number. Like all of these things, they will be numbers. Okay, when you evaluate, they will be numbers. Okay, so in the calculator, so for some calculator instruction, can you see my calculator on the right top? It says RAD, but I think for yours, it might says DEG. Okay, so what's the difference? We will learn radius form later for right angle triangle, but if you can see, I will go to the setting in the front page and go to the document setting here. In the second one, there's an angle. Can you see that? There's an angle. It called radian, degree, and gradient. But I'm not using the last one. In method, we use radians after year 11. We start learning circular functions. But in year 10, I think for the first couple of exercise, we have the degree mode. Okay, we have the degree mode. So what's degree mode? Degree is 30 degree, 40 degree, 45 degree. And what's the radius form? That's pi. Okay, that's pi. We use pi to represent degree. We'll learn that later. But let's set as degree mode first. Okay, set as degree mode. And then I will go to number 4, current. Still open that page. Okay, still go back to the same page. Okay, and sine 50 degrees. You see the degree, the unit degree on top? If you set that into the degree mode, can you see my degree here? If you set into the degree mode, you don't need to type the degree anymore. So you can just say that's a sine 50. So where sine is in the trig next to the equal sign, okay, next to the equal sign, there's the sine 50, well, degree. I should type the degree, but because I'm already in the degree form, so I don't need to type the right corner circle there. So I'll type enter. That give me this, okay? If I just type enter, it will give me cosine 40. But it's not the ratio, okay? I can't see what the value approximately should be. So I will press Control and enter again. Control and enter. So that will give me the approximation value. The calculator will try to give you exact values at the beginning, but after you press Control and enter, it will give me approximation values. Okay, Control and enter give me decimals. So the requirement is to correct to 2 decimal places is 0.77. Okay, approximately 0.77. Okay, cosine 72 degrees. Someone keep talking over there. Can we just stop talking, please? Okay, cosine 72 give me 0.31 approximately. Okay, 0.31. You must set that setting in degree. If it's not in degree, if you put in radius form, it will give you a different answer. Okay, it will give you a different answer. So in hello, can we stop talking, please? So 0.31 for that one. Okay, and tangent 33, we have tangent 33. Well, it's basically you use CAS to do it. 0.65 for tangent 33 degree. Okay, next example. Next example, this one is to help us to find some missing lengths. Okay, if you know one angle in the right angle triangle and you know one length, you should be able to find all the rest. Okay, you should be able to find all the rest. If I can use a diagram to represent cosine 20 equals to x over 3, what diagram I should have? Yeah, a right angle triangle. And I'm talking about 20 degrees, maybe is this one. And I have cosine 20 degrees equals to x over 3. So 3 will be the hypotenuse and x will be this length. Basically, I'm trying to find the adjacent. Okay, I'm trying to find the adjacent length to the 20 degree angle. But like, I don't need the diagram, I can still solve for it. Okay, I can still solve for it. I'm solving for x, and also you know cosine 20 is a number, okay, 0 point something. So x will just equals to 3 cosine 20 degrees. Okay, just equals to 3 cosine 20 degrees. So if I can open the calculator, okay, 3 times cosine 20. Control and enter. 2 decimal places, 2.82. Okay, 2.82. Okay, so this length is about 2.82. What you need to see is sine some degree, cosine some degree, tan some degree, that's a value. Okay, that's just like 4 or 5, like same as a number. When you treat this as a number, you can easily solve for the variables in the equation. So when you want to solve for x, we just times 3 on both sides of the equation, and I'll get x equals to 3 cosine 20 degrees. Okay, that's the first page. Okay, it's the revision for year 9 ratios. And see the next example, please. Okay, the next example will give you a diagram, give you one angle, and ask you for some missing lengths. Okay, ask you for missing lengths. The angle given to us is 31.3 degrees, and this one is the adjacent. Okay, the given value is adjacent, and this given, like, this is the variable. What I'm trying to find is the hypotenuse. Okay, it's the hypotenuse. adjacent and hypotenuse, that ratio will be SOHCAHTOA, so it will be the C. Okay, so it's the cosine. So cosine 31.3 degree equals to adjacent over hypotenuse is 0.05 over h. Okay, 0.05 over h. Remember what you're trying to solve. I'm trying to solve for the hypotenuse. I want to make hypotenuse to, this hypotenuse is B. I'm trying to solve for B. So B needs to be the subject. What I can do is B times cosine 31.3 degrees equals to 0.05. And B equals to 0.05 over cosine 31.3 degrees. Okay, after that step, I can put into the calculator. Or what we can do, we can directly solve for it by the first line. Okay, we can directly solve for it by the first line. So what I can do here is, I can go for menu 3 and 1. Okay, hopefully you can see it. Menu 3 and 1 to solve. Okay, algebra and solve. So what I'm trying to solve is cosine 31.3 degrees equals to 0.05 divided by the variable b. Okay, after you type this equation, you need to tell the calculator what you're trying to solve. So you press comma of the variable b. Okay, I'm trying to solve for b. This in the bracket you press comma b is indicate what I want to solve. Okay, what I want to achieve. So I want to achieve b, the value of b. So it's cosine 31.3 equals to 0.05 over b, comma b. Equal, okay, b gives me 0.0585. Okay, that's the value of b. I can solve that directly. Or you can rearrange it by yourself. Okay, just rearrange everything by yourself, and then as what we'll have is 0.05 over cosine 31.3. So I can type that in directly as well. So two ways to do it. Solve at the beginning, or you can rearrange it by yourself and then type a simple equation. You don't need the solve function now. So that gives you the same value as well. Okay, give you the same value. Two decimal places, I have 0.06. Okay, b is approximately 0.06. Okay, that's this one. And for the next one, okay, for the next one, we have x and y and 5. If you keep talking, I need to separate you too. Okay. X, y, and 5. You have 30 degrees. We can see well, if you have x and y, they are opposite and adjacent. That's a tangent. But I can't solve out anything if I set up x and y in one equation. If I said tangent 30 equals to x over y, then what I can solve? I can't solve out anything. So I need to put x and 5 together and y and 5 together. So what I'll do is assign 30 degrees equals to x over 5 and cosine 30 degrees equals to y over 5. Okay, I set up two equations separately and I can solve them separately and I can get the value of x and y. So x equals to, well, if I put that into the calculator, you can see, you don't need to know this, but you can put into the calculator, you can see x should be 5 over 2 and y should be 5 root 3 over 2. Okay, 5 root 3 over 2. And if you press the control enter, that will give you the approximation value. Okay, because the time, I don't have enough time, I'm not going to show this calculator thing. It's exactly the same as the first one. Okay, I think the hard one is the third one. Okay, the hard one is the third one. Everyone's kind of like stuck onto this one. But this question is actually very interesting. If you can see 50 and 25, okay, 50 and 25. this 50 is the exterior angle. You know the theory, like the exterior angle will be the sum of those two. So if you can do that, that will be 25 degrees as well. Okay, you can think about the angle, like what angle do we have? We can label all the angles. Okay, because that's 130 degrees, so that will be 50 degrees in total, so that's a 25. If that's a 25, 50, and that's a 40 degrees, I think. 40, 50. So that's all the angles I can label. But it's the important is 25 and 25. That will be isosceles triangle, right? That's an isosceles triangle. But I can't do any sine, cosine, tangent thing in this right angle triangle because it's not right. Not in this triangle because it's not a right angle triangle. I don't have sine, cosine, and tangent in this one. But what I can have is I know this length will be 10 because it's isosceles. Okay, those two pink lines equals to each other. So that top part give you 10, so this part will give you 10 as well. Therefore, I can use this right angle triangle to talk about things. Okay, I'm looking for the x. I know the hypotenuse. So what I can set up is a sine 50 degrees equals to x over 10. Okay, sine 50, or you can say cosine 40, it will be the same thing. You can say cosine 40 equals to x over 10 as well. It will be the same after you solve for it. The ratio is the same. I use the isosceles triangle property. I know the two lengths must be the same, so I find the hypotenuse of the right angle triangle in the smaller one. Yes?
So you know what the whole triangle.
I will say A, B, C, D for you. Which triangle you talk about? A, B, C, yeah.
Yeah. So the angles, like those triangles you have around to add up to 180 degrees.
Yes.
ABC is add up.
90,
Oh.
90, 50, 40. That's 180. The 50 is not that angle. The 50 is this one. Okay? It's add up to 180. And all of them will add up. Three triangles will all add up to 180. Okay, so I have sine 50 equals to x over 10. It backs to a really simple question now. Like I don't need to see this triangle anymore. It's only the small right angle triangle here. So I have x equals to 10 sine 50. And I can put that into the calculator. So 7.66. Okay, 7.66. Okay, that's this question here. And for the next one. Okay, next one is really important. Why is important? Because it's the rounding thing. That's what I want to talk about. Okay. I'm not sure if I have talked about this before, but I'll say it again if I did before. When you try to do rounding, okay, the rounding only happens in the last stage. Okay, the last step you do, you put that into the calculator. Control Enter, round it. You're not going to do the rounding every single step and add all the rounding number together. Okay, you not do rounding before the last step. All the rounding needs to happen. You keep all the exact values and then do rounding at one time in the end. Okay, for example, I'll show your examples to this one. Okay, you're not going to do the rounding before, okay, before the last step. So find the perimeter of the following triangle, correct to 1 decimal places. Okay, this 1 decimal places needs to be round in the end. Okay, in the end. So show you this. So what I want to find, it will be the ABC value, right? That's what I want to find. Well, instead of say C, I will say that's C, that's D. So I will add A, B, C, and D together to give me the perimeter. Okay, to give me the perimeter of this triangle. Okay, A, B, C, D. So what I want, if I want to find A and C value, I need to use the 20 to help me. So I can say a tangent 60 degree equals to 20 over C. Okay, equals to 20 over C. And C times tangent 60 degree equals to 20. And C equals to 20 over tangent 60. Okay, that's the first thing we have. Okay, that's the first thing we have. And I'm also looking for the A value. So I will have sine 60 degrees equals to 20 over A. Okay, so opposite over adjacent. A sine 60 degrees equals to 20 over sine 60. Not 20, equals to 20. And then A equals to 20 over sine 60 degrees. Okay, that's how I find A and C values in the left-hand side right angle triangle. I'm doing a little bit faster, but I'm pretty sure you can rearrange this by yourself. It's kind of revision thing. And I also need B and D. Okay, I also need B and D. So if you look at B and D, I have tangent 25 equals to 20 over B. Okay, D times tangent 25 degrees equals to 20. And D equals to 20 over tangent 25 degrees. Okay, that's how I look for D. And the last one will be a sine 25 degrees equals to 20 over B. So B sine 25 equals to 20. B equals to 20 over sine 25 degrees. Okay, I make it smaller for you to look at it. I use two right angle triangle to find all the lengths, okay, around the A, B, C, and D. I find the four lengths, okay. Now I just need to add them to find the perimeter. That's what I'm trying to talk about here, okay. Be careful. I can't put those four into the calculator and round to one decimal places and then add, okay, that's wrong. I can't evaluate them now. If I evaluate them and leave one decimal places only and then add, it will be called a double rounding and the error will accumulate it. For example, if you add them all together and round, that will give me, for example, 0.2 in the end. But when you accumulate accumulate the error, you round this one. For example, this is like 0.54. You round down. But every single one after that, you all round up. So you round up actually 3 times. The answer then you add together will be larger than what you round all together. So you have it's not accurate for 4 times already. So what we should do is we just put this expression into the calculator and then press Ctrl Enter to give me a final rounding value. Not rounding them before, okay? You're not rounding here. You round it in the last step. You only see Ctrl Enter for the final result. You don't do Ctrl Enter before the final result. Okay, I hope that can make it clear. Because when you round it before, they will accumulate error and it's called double rounding. Double rounding will increase the error. Yes? All of this like this into the cast and Ctrl Enter. Yeah, and then Ctrl Enter. Just say perimeter equals to 20 over tangent 60 plus 20 over sine 60 plus 20 over tan 25 plus 20 over sine 25. And then press Ctrl Enter. Okay, here. Okay, we only press Ctrl Enter here, not before. don't do double rounding. You don't round anything before your final result. Okay, you don't round anything before your final result. I hope I can't see anyone have this mistake in the application task, because you will definitely be asked something like this. Okay, so don't get this wrong. Alright, last example. Last one. A right angle triangular flag is made for the perimeters of school competition. The second longest edge. What's the longest edge in the right angle triangle? Hypotenuse. A flag maybe better draw that way, or maybe this way. Okay, so let's say that's a flag. It's a right angle triangle, and it says the second longest length of the flag is 25 centimeters. We say that's 25 centimeters. Okay, one of the straight line, and the largest non-right angle, the second largest non-right angle on the flag is 71 degrees. So that's 71 degrees. Why that's 71? Because this length is longer than this one, right? This is the second longest one. Then this angle will be larger than this angle. So if the angle opposite to a longer length, then this angle will be larger as well in the triangle. Okay, not only in right angle triangle, in any triangle, if you opposite to a longer length, then the angle itself will be larger. So this is longer than that, then this angle will be larger than that one. So the 71 degree will be here. Okay, the 71 degree will be here. And find the length of the longest edge to the nearest. Well, this is what we're looking for. Okay, hypotenuse is what we're looking for. So looking for the longest one. So that's what we're looking for. So what we have is sine 71 degrees equals to 25 over h. Okay, opposite over hypotenuse is the sine. So h times sine 71 degree equals to 25, and h equals to 25 over sine 71 degrees. See, I still have a final expression for the final answer, and then put into the calculator and press Ctrl and Enter. Don't round it before, okay, before that. Don't round, for example, sine 71 degrees. That's not right. So what we can do is 25 over sine 71. Control and Enter. Give me 26.44. Nearest millimeter. Okay, nearest millimeter. This is in centimeter. Millimeter is 1 decimal places, right? It's the 10th place. So it's 26.4 centimeters. Okay, this is round to the nearest millimeter already. You don't need to give your answer in millimeters, but you will round to that place. Okay, so the 10th place is the millimeter. So I'll round it to 1 decimal places. That will give me 26.4 centimeters. Alright, that's all for the first exercise, and I have uploaded schema for you already, so you can work on that tonight.